in the longline fisheries in both of those areas. They both have issues with, in North Carolina with pilot whale bycatch, and then in Hawaii with false killer whale bycatch in the longline fisheries.
Okay.
So we have researchers in both places testing a whale-safe weak hook. So it's a circle hook that is designed to be strong enough to retain tuna, but weak enough to bend when a large cetacean is caught. So the whales can actually pull the hook, stretch it apart, and slip off the hook if they've become caught.
Oh, okay, interesting. So that's a circle. Okay, and that's different from, what is it, a J hook? Is that what's normally used, or what has been used?
J hooks are one type of hook that was traditionally used, but more and more recreational and commercial fisheries have moved to circle hooks because they're better at reducing bycatch, and they're much better at retaining animals alive. So they are designed to only catch in the hook in the corner of the mouth, whereas J hooks can become swallowed more deeply and hook into internal organs of target fish and bycatch animals. So more and more fisheries have moved over to the circle hooks.
Okay, and you mentioned the recreational fishery. Now, when I think of recreational fishery, I think of your average John Doe go out in their boat and fishing from their rod and reel. Do they use? Is it more of the recreational fisher, the big recreational fishing companies that take people out, or is it more like individual recreational fishers that have switched over to these hooks, or do they even bother?
Actually, I think recreational fishermen were actually the first to switch over to circle hooks because they noticed a difference in the survival rate of the fish. Because so many recreational fishermen are catch and release anglers, so they want to ensure the survival of the fish when it's released. So they were the ones who kind of first adopted those techniques, and then it moved over to commercial fisheries.
Okay, and are they active in, are they part of the was it the blue water fishing industry, or is it
the Blue Water Fishermen's Association is actually commercial longliners.
Okay, do you have a recreational fishery sort of group that works in the consortium, or is it more of just on a sort of like a colleague basis that you know of people who, in the recreational fishing industry?
We don't work specifically with any recreational fishermen right now. It's more. There are so many parallels between recreational catch and release fishing and bycatch discards that it's been something that I've been learning a lot about. And I attended the Circle Hook Symposium in Miami this year.
Okay.
And so that was it was about half recreational fishing, half commercial fishing, and a lot of the techniques are go both ways.
Oh, okay. Okay, great. Okay, perfect. Okay, so you mentioned before the science industry partnership. Why is it so important for that science industry partnership?
Well, one of the main priorities for the consortium is really that any of the bycatch mitigation techniques that we develop, they've got to be practical for the fishermen. Mm-hmm. If it's cost prohibitive, if it requires a lot of additional training, techniques will be met with resistance or they won't be adopted at all. And in many places around the world, where bycatch is a serious problem, it's these artisanal fisheries that don't have a lot of resources to make changes. So we want to work with the fishermen first to give us an idea of the limits of the resources that we have to work with. And fishermen also have very valuable local ecological knowledge that they bring to the table and their own ideas about bycatch mitigation. Some fishermen might have developed, they see bycatch of X species as a problem. So they've figured out on their own already how to avoid it. Mm-hmm. If it's fishing in a different area, or if they've made a change to their gear that seems to work. And, they do it, but maybe they haven't shared it with all of the other fishermen in the area. So they bring a lot of ideas about mitigation.
Yeah. Oh, absolutely. I mean, even we mentioned that we were discussing in the pre-interview how much we learned from just talking to fishermen. I mean, it's really a marine biology course in itself. And probably what universities should do is have fishermen come in and teach what they know, because they know so much. And they're not only just, they're fishermen, but some of them have like engineering sort of skills, where they design, like you say, they may design mitigation techniques, or may design a tool that can come up with that, or they may think about it and have somebody design it. So it's really good that we get their input. Because did you find, or has the consortium found that there's been or that there was an initial problem with sort of the fishing industry not trusting science, in terms of like, if they find out that the bycatch is more serious than they initially thought, they're just going to turn on us and shut down everything?
I mean, that's also complicated topic, and definitely something that is it's hard to say something about the entire fishery,
right,
or
of course,
all fishermen.
Yeah.
And I would say that we work very closely with lobster fishermen in Maine, Massachusetts area through the Maine Lobstermen's Association.
Okay. And
they're dealing with some pretty heavy issues regarding the right whale entanglements, and the regulations that they've had to deal with. And so it's a complex relationship, but we found that if you go and talk to the fishermen and hear them out, they're willing to talk. They want to talk about things, and they want to especially be involved from the beginning of a process. They don't want to feel like they're being regulated from the outside without any input.
Right.
So I think it's important to have fishermen be a part of the process from the onset.
Oh, absolutely. I completely agree. I think oftentimes they get demonized in the media. You're always saying, we're everybody's saying we're overfishing, or the fishing industry is killing all the fish, this and that. But in reality, they just want to sort of live their lives and make a living, but they don't want to see the ocean sort of go to hell in a handbasket.
Right.
So they're all. I found when I speak to them as well, during my studies, it's often very positive outcome, and I tend to learn a lot. I don't know if they learn a lot from me because they probably know a lot of the stuff, but I definitely learn a lot from them. So that's good. Okay, so let's get into the last portion of the interview. Probably the most important part. I mean, we sort of touched on this, but let's talk about moving forward and sort of the goals of reducing bycatch. And the question I'm going to ask, what is being done to reduce bycatch? It's very general, because even looking on your website, you look at the database, you look at all the different types of mitigation, of reduction mitigations techniques that there is available. It's quite a bit, and it would probably take us a lot of time and energy to go through all of them. Can you just sort of pick one or two sort of reduction mitigation measures that the consortium has focused on in the past, say the past year or so, and like you can even go with circle hooks or things like that, something that's more popular in that people would recognize. Can you just talk about one or two of them and how they actually reduce bycatch?
Sure. I guess first I want to say that because bycatch is a global problem and it's happening in so many different types of fisheries, there's never going to be one cure-all for everything. Even if something works in a gillnet fishery in the U.S., it might not work in Australia.
Okay. Now, why would that be so? Why wouldn't it work? Like if it worked in the States, why wouldn't it work in somewhere like Australia or the South Pacific?
Depending on what the bycatch issue is, there are different species in different places. So like basic biology has to come into play where. So sometimes like with the pingers, it will work for certain dolphins, but it might not work for another species.
Okay.
It
all depends on sort of their behavior, their physiology, where they are, where they occur, and I guess what other fish are around as well. Mm-hmm. Okay. Sorry.
I've talked already a little bit about one of my favorite projects is the weak hook, the whale safe weak hook.
Right.
It's just such a simple solution. that will retain the target catch for the fishermen. They don't have to make any major changes to the gear. It's something that can be mass produced. We've seen success with whales being able to straighten the hooks. And it's actually also being adopted in the Gulf of Mexico for the bluefin tuna fishery, to release the bluefins. Because they're so much bigger than the target catch, that they're also able to straighten out the hooks. So that was featured in the New York Times recently.
Okay, so it really has to do with the weight of the fish or mammal that it's being hooked. So with their weight, they can sort of use that to their advantage and straighten out the hooks. Once once that happened, and the hook is retrieved. I guess the hook stays on the line. Is that correct? It doesn't stay in the mammal. So once it's retrieved back on the boat, can the fisherman again bend that circle hook again, or is that hook done?
I think that hook is probably done, but the hooks themselves are not that expensive, and so the loss of one or two hooks from being bent isn't a significant problem for them.
Okay, good. Okay, sorry, so go on, maybe one more example?
So I guess one of the other really interesting projects that we're doing that I haven't talked about yet is we do a lot of work, as I said, with the North Atlantic right whale population and their interactions with the lobster fishery.
Right.
And because there's so few right whales, and because they're endangered, and because we don't really see the entanglements happen. We see evidence of entanglements through scars on their body. We find whales trailing gear often, but we don't see it happen.
Okay, so sorry to interrupt. Just before we go on, can you describe sort of how lobsters are caught? Because it's a little different than what we've been talking about with other examples.
Of course. So lobsters are caught in traps or pots. It's a cage that sits on the bottom of the seafloor. It has little doors and stuff for the lobsters to go into. And the fishermen mark them with a vertical line going to the surface and a system of buoys on the surface. And sometimes they fish just one pot at a time, but more often it's a trawl of traps. So they're all attached to each other. It can be a pair, it can be up to like 20, 40 all in a row.
Okay.
And so they're attached with a line together.
Okay.
And in the past I said the line was floating, but they've switched to a sinking line, so the line sits on the bottom of the seafloor, hopefully to prevent entanglements with whales.
Makes sense.
But there's still vertical lines in the water that the whales become entangled in. There's still some lines on the surface.
Right.
And the whales, the entanglements are so complicated, and we've got some examples of them on the website. But, they get wrapped around the flippers, they get wrapped in the baleen, they get entangled around the caudal fin. They're very complex interactions with the lines, but we haven't really figured out how it occurs.
Right.
So we've been working with an engineer at Duke University to model those interactions. He worked with biologists also from Duke to figure out in all the proportions of the whales, how they move through the water, the biodynamics of everything, and then the dynamics of the fishing line and how the rope interacts with differences in currents in the water.
Right.
So we're able to kind of model, like fly the whale through into a rope and see what will happen, see where it'll get entangled, see what kind of movements need to occur for that entanglement to happen.
Right.
So we're trying to look at those kinds of things in the absence of being able to do experiments in the water. We can't purposely entangle a whale.
Of course, no.
So because you can't do those experiments in real life, you need to start, especially with marine mammals and endangered species, you need to start thinking of outside the box and thinking of ways to engineer things and test. The other amazing use of the model is being able to test different types of gear through the model and see how effective they are before just implementing them in the fishery.